So, in the drifting continents that we're going to talk about, there was a several scientists who made early observations that suggested that the Earth at some point was a supercontinent that was joined together. And this really didn't gain traction, even though it really did seem like the best puzzle pieces did fit together, until Alfred Wegener came along, and he was a German meteorologist that realized that these fit together, and he began accumulating and doing different expeditions where he gathered a bunch of evidence about how that evidence that supported this hypothesis. So he wrote a book called The Origin of Continents and Oceans, and he rewrote it 4 different times before he passed away. Every time he came up with new evidence or people criticized him and he wanted to answer their questions, he kept updating it. So we're going to go over the different evidences that exist. So Wegener proposed continental drift, which shows that all continents joined together in a supercontinent called Pangaea. And here's about what that looked like. So in this model, here's what the continents looked like. In this model, it sort of looked like this at some point and started to spread apart. It spread apart further and further until we have what is seen in present day. And I want to point out on this that this little area up here is about where North America goes. So this is about North America, which is actually not too far from the equator. And because of that, anciently, North America was a lot more like an equator area, where now we're like way up here. We were closer to the equator, and that made our area tropical, humid, lush, like everything you would expect on the equator. Not a lot of freezing and thawing like we have now up high. So Wegener collected and organized rock climate data and different fossils to support his hypothesis. And we're going to go through and talk about that. So if this idea of a supercontinent is true, there are certain things that you would expect to see. You would expect to see that rocks are joined together in certain places where it was joined together formerly, that it would have the same rock layers and striations. And indeed, you do find that in certain places. So you can see that these match, this matches, and here this mostly matches. Like this matches over to here. The blue is rock formation. The purple is mountains, a mountain range that matches the layers all the way down. Then you would also expect to see fossils that are the same. Because if these were joined at some point, you would expect that the animals didn't know that this would split in a few million years, so they walked from place to place. Like as it was joined here, they would just walk back and forth. So indeed they did, and the fossils match all the way across in different areas where things were joined in the past. Additionally, you would also expect to find climate evidence, but how could you know how hot or cold a place is? Well, you can tell, as we learned previously, that you can tell about how hot or cold a place is by the types of plants that grow there. So the plant fossils that are found look very tropical in places that we think used to have tropical, used to be closer to the equator. And indeed, that is found as well. Interestingly, as well, I want to show you that in this place here in South America, Brazil is actually a huge, massive country. It's very big. So Brazil is about right here, which matches really well with West Africa. And Brazil can be very rich in some oil deposits and rocks, and you find those same resources and fossils in West Africa. So additionally, as land goes past, you would expect to see like glacier evidence in these places. As glaciers go through land, glaciers do move. And it's this giant solid piece of ice that really cuts through and carves through the land and scratches it as it goes through and sometimes leaves deposits. And you do see matching glacier deposits in different places. So, a lot of people during Wegener's lifetime, this is a picture of him, rejected his hypothesis. And this, on this expedition, unfortunately, he actually died. I think he was about 50 years old. You can read his story online and how he died. It's actually quite it's a sad story. And he really pushed through too hard, and went to too big of extremes. However, in the meantime, he did gather a lot of evidence about this, and later his hypothesis has become widely accepted. The two reasons why it wasn't in his lifetime, unfortunately, is that he couldn't explain the force that would move giant continents across, nor could he explain how a giant not just what was doing it, but how it was moving it. Was it on rollers? How was it moving these giant continents? And we'll talk about that. So both the force of what was caught, the energy source to make that giant move, but also the method, how it would be moved. So those are the two reasons why his hypothesis was rejected, and we will go through those in future sections.